Hi, everybody, and welcome to it was supposed to be Friday review session where I would go over all the answers, but because the quiz was due on Friday, I wanted to wait a day so everybody had the same advantage. I actually ended up reassigning the quiz to everybody, so feel free to retake it. You have until Monday, but this will not happen in the future. The reason I reassigned the quiz is twofold. First, there were a handful of people with valid reasons to request an extension, and so I just extended that to the rest of the class. And second, I was a little concerned that a lot of you use ChatGPT for the quiz, which is fine, generally speaking. But there's a way to use ChatGPT, and that's what I want to talk about. So first of all, I think most people understand, myself included, you have a lot of work on your plate and you want to get an A without putting in a ton of effort into this course. And that is how I designed the course. So you don't have to put in a ton of work to get an A. If you watch the lectures, do the homeworks and quizzes collaboratively, independently, using outside sources, but doing the problems yourself, you will get an A. That said, I think it's going to be about the same amount of effort, whether you copy and paste the quiz questions into ChatGPT and then copy and paste the response back to the quiz, or you think about the quiz question a little bit. Maybe you use ChatGPT to check your answer or to confirm your answer, and then submit the quiz. You're going to be doing roughly the same amount of work either way, but with the former approach, you're not really learning. You're copying and pasting without much thought as to how ChatGPT got the answer, and that is not. The material in the class is not going to be absorbed in that way, right? The quizzes are meant to practice what is gone over pretty quickly in lecture. And, I don't want to sound harsh, but the honor code does apply. So if there are future instances where I notice people are using ChatGPT, no matter how widespread, in a way that's not building their understanding, to be clear. You can use ChatGPT, but in a way where you're just copying and pasting the response, I will have to report it. And I don't want to do that. So please do not use ChatGPT on the quizzes, except to check your answers, confirm your understanding, or, explore how to get help. And if you're unsure, you have a lot of resources outside of ChatGPT available to you as well. You can shoot me an email. I'll respond pretty quickly. You can schedule in office hours, or you can post to Canvas. So there's a lot of options to get help. I think ChatGPT will do pretty well with this earlier material, but the material is going to get more advanced, and it's going to become more and more obvious if you're using ChatGPT to get the answer, because it will not be correct. So yeah, please just be mindful of how you use ChatGPT, and my hope is that you learn in taking this class, and that means watching the lecture videos and doing the questions independently, getting help as you need it, but not just blindly copying and pasting without understanding how ChatGPT got that answer. So all of that said, I want to get into the first question. You might recognize the numbers here as from the first question on the quiz, where you're asked to calculate quartile 1, 2, and 3, which hopefully you know from the lecture is synonymous with percentiles 25, 50, and 75. But I think it's easier to think about just that word quartile means you're splitting your data into quarters. And so the very first thing is to order your data. So let's do that really quickly. This is what the data looks like when it's ordered. And quartile 2 is definitely the easiest one to get because it's the 50-50 split, also known as the median. Sorry about that. And so after the data is ordered, right here, if I cut the data right here, I will have a 50-50 split. And earlier I told you that when you have an even amount of data, you take the average of those 2 points, which most of you did, and you got 4 as the correct answer. But I wanted to clarify, because I spoke about this with the professor. Actually, anything that splits the data in half is a valid median. So anything from 3 to 5 would split the data in half. You could have said 3.1, you could have said 4.9, because any of those values do split the data in half and are valid answers for the median. That said, the most common convention is to take the middle of that range, which is the mean, because it's you could think of it like a flat distribution. So the median, mean, they're both the same in this symmetrical measure. But the common convention would be 4. Now to get the quartiles, you would split it in half again. So now I'm going to look at just this half to get the first quartile. And to split it in half, I see that this data point perfectly splits the data in half, with one on the left side and one on the right side. So 1 would be quartile 1. And then similarly, to get quartile 3, I look at this half, and in the middle is the data point 5. That said, there was one student who went above and beyond and checked his answers in JUMP, and JUMP gave 5.5. which was strange to me, so I asked for help. And what I learned is that when you don't have a ton of data points, in this case we have 3 to split, some people will take like a median as a measure of center between the min and max. Some programs, I should say, not some people. I think the vast majority of people would have put 5, and that is the correct answer and the answer I was looking for. But different programs have different approaches to solving problems. R would have given you 5 for quartile 3. However, JUMP gives you 5.5 because it's looking at the range, including the median, and it's saying between 3 and 7. No, that's not quite right. Well, it's calculating the median as 4. So between 4 and 7, exactly in the middle, would be 5.5. Because it's basically saying I don't have sufficient data to calculate the quartile in the way you all learned. I personally am not a huge fan of JUMP's approach, but I did want to share that for the student who, came across it. Just so you're aware, there's different opinions and different approaches to do this problem. That said, I do hope that you follow, I think, the most popular convention, which is just to split the data in half. And in the event that you have an even number of data points, just take the middle of those 2 data points. That said, as I learned, anything in that range is also valid. So let's move on to the next question. So most of you did get this question right. Unfortunately, it wasn't in the way that I taught you and the way I was hoping you would get the question right. So the trick here is you're told about a mean and a standard deviation, and the real key is that I tell you you can assume the dispensed volume of coffee is normally distributed. So you know some things about the normal distribution from the past lectures. And one of the key properties, there's a lot of properties to the normal distribution. It's symmetric, it's centered at the mean, but if you know the mean and standard deviation, roughly the percentage of data that falls within 1 standard deviation, 2 standard deviations, and then 3 standard deviations. And we call that the empirical rule, and that's something that I presented to you guys. So here we're told that the mean is 8 fluid ounces and the standard deviation is 1 fluid ounce. So if we go back to that chart on the empirical rule, you can replace mu, which is the population mean, with 8, and you could replace sigma with 1, right? So 8 minus 1, this is going to be 7. 8 minus 2, this is going to be 6. This is going to be 5, right? So you have 5, 6, 7, 8, 9, 10, 11. And so those are the key. Well, they're not really key. They're no more significant than any other realizations. However, if you want to apply the empirical rule, you know for 1 standard deviation, 2 standard deviations, and 3 standard deviations what percentage of the data will lie in that range. So remember, this is where 6 fluid ounces lives. So you could do some very basic arithmetic to figure out the percentage that would be less than that. So there's 95% from here to here, which means there's 2.5% on either extending past those points. So 2.5% on this tail and 2.5% on this tail. And that's the answer I was looking for. I was looking for 2.5%. A lot of you said 2.28%, which isn't a more accurate answer. However, we haven't gone over how to get that. And I'll show you right now. It's not difficult to get that. So if you look up a z-table, and you remember z is just another word for standard normal, and you look up, this is the number of standard deviations you are away from the mean. Because remember, the standard normal is centered at 0. So minus 2, and what's the standard deviation of a standard normal? It's 1. So minus 2 would be 2 standard deviations away from the middle, which is what we're looking at. And you could see it's 0.0028. Or you could plug it into statistical software and say, 2 standard deviations away, what percentage of the data is less than that? And both of those approaches will get you 0.228. Why is that different than the approach using the empirical rule? Remember, the empirical rule is an approximation. So these are rough estimates. And if you Google the empirical rule, you will see it sometimes written out to 2 decimal places. And if you write it out to 2 decimal places, you will get the right answer. But nobody's expecting you to memorize these numbers out to so many decimal places. I think the main, if you remember these 3 numbers, that's more than sufficient for the empirical rule. And at the end of the day, 2.5% and 2.28%, it's not a huge difference. So yeah, that's how I wanted you to get the answer. I would recommend doing other practice problems involving the empirical rule if you did use ChatGPT to get this answer. They're going to be very similar and very familiar since we've done this problem together. So you could do any other problem involving the empirical rule. They all follow this same structure of identify the mean, identify the standard deviation, and then figure out how much area is to the right or to the left or in between, which you can do with basic arithmetic, knowing the empirical rule. Let's move on to the last question in the quiz. So this one was about standard deviation, and I was a little surprised at the amount of people who struggled with this, which is another reason I decided to extend the quiz. And please keep in mind, I'm not going to be extending the quiz in the future. So please, take it seriously and take your time. There was really 2 kind of, I don't want to say traps, but 2 common errors that you could fall for. The first thing, and we emphasized this a lot during the lecture, is that the formula for standard deviation varies based on whether you're looking at the population standard deviation or the sample standard deviation. And in this case, the question tells you quite clearly that you're looking at a sample. And in fact, the vast majority of the time you are looking at the sample, because if you know the population, you know the truth. And there's not a ton of value to measures of uncertainty around that truth. So it's just very unrealistic as statisticians to have the entire population. So you're going to be using this formula almost every single time you have a question about standard deviation, but I do want you to be aware that this is the formula for population standard deviation. Very similar. The main difference is in the denominator. We're taking away 1, which you could think of, you lose that from estimating the mean with x bar as opposed to the true mean mu. And some people were a little intimidated by this formula, which is totally reasonable. Mathematical notation is very intimidating for everybody. So I just want to kind of go over the intuition behind it. So if you want to get deviations, which is, how much your data varies from its expectation, which you could think of as the mean, you take differences, right? You take, this is the data I observed, and I expected it to be the mean because that's the most likely value in a normal distribution. But I expected it to be close to the mean, and instead I got this. So I take this minus the mean, and that's what's happening in this part of the formula. Now the issue with just subtracting off the mean from each of your data points is some of them are going to be negative and some of them are going to be positive, and you don't really care whether your deviation is to the right or to the left. You're just trying to get a measure for how much, what the size of that deviation is. So to get rid of the negative signs, we square it. But in squaring it, we make the numbers more extreme, right? Larger numbers get even larger. Numbers larger than 1 get even larger. Numbers smaller than 1 get even smaller. So we kind of want to undo the squaring. The squaring does make them all positive, but it also makes them more extreme. So we undo it by taking the square root. So that's a little bit of the intuition behind taking the square root here and squaring it here. And then the last step is really kind of like what you do when you're taking an average, right? You add up all your data points, and then the last step is to divide by the count. But in this case, we're not quite dividing by the count. We're dividing by the count minus 1 for the reasons we shared earlier. So let's do this problem together right now. The first thing we have to do is calculate the mean of these data points, which is very easy to do. So you could do it right here in your browser. 2.9 plus 2 plus 0.6 plus 1.1 is 6.6, and then we could do 6.6 divided by the count, which is 4, and we get a mean of 1.65. So now we take each of these data points and subtract 1.65, right? And we're going to get some value. It's not important what it is. And before we sum up all of those individual values, because some are going to be negative and some are going to be positive, we square them. So let's just be pedantic and do the whole problem out right now. So we know the mean is 1.65. So I'm going to take all these data points. I'm going to subtract 1.65 from all of them. And I'm going to get a new set of data points. And you know what? It might be easier to do this in a program like Excel. So I'm going to show you how to do this in Excel real quick. So here's our data points. We'll do data, text to columns, delimited by commas. So that just splits my data points into different cells. Okay, and I'm going to do this cell minus 1.65, which is the mean. I did equals instead of minus. So minus 1.65. And this is my first deviation. And now here's all 4 of my deviations. But again, like the intuition I shared earlier, we don't want them. The positive and negative isn't important. So we're going to square all of them. Great. So now I square them all. And lastly, I sum them all. So now I have the sum of the squares of the deviations, which I messed up that formula. But it's sum of all this. Okay, so this is the sum of the squares of my deviations. I'm not done yet. What else do I still have to do? Well, I look at my formula. Before I take the square root, I have to divide. The order of operations is very important here. I have to divide by the count minus 1. So I think a lot of people divided by 4, and you only do that when it's the population that you're looking at. In this case, we're looking at a sample, so we're actually dividing by 4 minus 1, which is 3. And we're not done. This is the variance. This is not the standard deviation. To get the standard deviation, I have to undo the square that I did in the beginning. So I'm just going to wrap this whole thing in a square root. And this will give you the answer that I was looking for. And many of you rounded, which was fine. I said to round to the nearest thousandth, at least. And most of you did that. So if you made a mistake, there was a few rooms for errors, a few places where that mistake could have happened, and I'm not exactly sure where. I didn't check every individual one, but hopefully in going through this problem, you've realized where that mistake might have happened. So I'm glad I could go over this quiz with you. I think I'm going to keep doing this on Fridays. Hopefully you guys ask other questions besides things related to the quiz and homework, and we can go over those things as well. But I think it'll be good practice to go over some common mistakes from the homework. Yeah, thank you guys for your time. Enjoy the weekend. And when we come back next week, please let's... I did my best to keep the work in this class to a minimum. So I hope that you can, do the homework on your own. And if you do get stuck, feel free to use tools to help you out. But that's what the tools should be doing. They should be helping to build your understanding. Don't use the tools for the purposes of getting the answer without increasing your understanding of how to get the answer. The material is going to get a lot harder. ChatGPT is not going to know the answer. And if you don't have these foundational skills, it's going to be really tough. So I'm trying to set you up for long-term success. I know I repeated this point a lot, but it's really important that you do these problems in a way that's building your understanding. Thank you, guys.